Right, today we are to start with the interface models. We have four interface models here. One is the report table, system interface table, user interface flow, wireframes, and display action response. These are some few things which probably you need not be taught as such because they are written as such, and I will show you how they are made, but there is not much to describe here. So first of all, the report table. A report table, you see everything, whether it is a table, it is an analysis, it is whatever it is called a model. So a report table is a model that captures the detailed level requirements for a single report. Common attributes of a report include the name of the report, the description, the decisions made from the report, objectives of the report, audience, trigger, data feed, data volume, frequency, display format, and calculations. These attributes should be specified alongside a prototype or example of the actual report when possible because it adds context for the textual information in the report table. So when you are giving somebody this report table, you must provide all the attributes duly described as well as a completely filled report, for example. While it is not necessary to complete all fields, the fields can be used to help identify what to think about when eliciting reporting requirements. So we will be talking about an example of this report table, which will show a prototype of the mobile application usage report. Figure 4.7 and 18 show the report table model. The model is split into two figures layered for sizing up, but is typically one table. So, but the first diagram shows it provides data for each store on the number of transactions, number of products per transaction, new mobile application downloads, and recipe uploads. This information allows the sales and marketing department to establish a correlation between the mobile application and recipe feature and the actual changes in the average number of products purchased in each transaction. There are many different types of report table templates. So you could create your own. This is just a sample. So that's why I was saying this is not much to describe. There is one example and provides one sample of the type of information that could be placed in a report table model. This is an example. So this is a failed example which can give you a fairly good idea. But you see, this is not some standard kind of a report. You can create your own report. Whatever you are doing, you can create your own columns, you can create your own data. You have completely a different report. But in this report, it is talking about the mobile application usage. And this report shows the number of applications downloaded, that is 10,732. Number of recipes uploaded, 6,907. Store ID here is 0. Region 0. Number of loyalty program transactions, 78,563. Number of loyalty program transactions by users with recipe uploads, 4576. Average number of products per transaction for loyalty with recipe transactions, 34, and average number of products per transaction for loyalty without recipe transactions is 10. So it is showing the total data in the first row, and then for different stores. 23548 store is in Central Texas, and it has got these many transactions. Then we have 54721 again in Central Texas, and the report numbers are different. 56098 again. So you see, this way you can make a report, and I am sure that the job you are doing, you might have been creating a lot many reports. So you know how to create a report. There is not much to describe. Next diagram shows the example of a top level elements in a report table. Meaning what? Each one of the items in this report table is described here. First element is the unique identification of this report. There must be a number for this report. Whether it is written on the previous report or not, but this number has to be allocated, and that is your reference number for this report. What is the name you have given to this report? Provide that name. Provide a brief description for this report. All of this data need not be shown in the actual report. Some of the items will be, like you see on top, we have shown mobile application usage report MAUR. So this is the name of the report. The description is not given here. Description is given in the details. Then what are the decisions made from this report? This format you can use for creating any report. So first you create this format, fill this in, and then you create your report. So you can see there are a number of elements here, continued on 2 pages, the previous one, and then it goes on, moves on, rolls on to the next page. So these two figures actually show the details of that. All the calculated fields, all the displayed fields, and what is the variable name for that, and what does it do. All of those details are here. So you can use this as a format, and you can create your own description or elements of your report table. What is the usage? Report tables are straightforward, can be created for each report, and are helpful to provide additional details about reports that cannot be gleaned by looking at a mockup. Using a report table with attributes allows the business analyst to specify the type of information to be included in the report, thereby ensuring that details are not forgotten or overlooked in the solution. When report data has multiple sources, the business analyst needs to define the system of record. The answer may require either a business or a technical decision. When mockup tools are available, teams may choose to use the tool instead of using the table. The business analyst should make sure that the tool provides all the same opportunities to capture requirements as are provided by the report table. Missing these opportunities can result in missed requirements. So the data in the report will not be complete if we are unable to capture all the data. What is the relationship to the requirements of this report? The information in the report table model represents the actual report requirements, therefore, no additional requirements are necessary. Stakeholders can use the report table and a mock-up of the report to fully understand the proper report requirement. So this covers the whole requirement about this report. Second is the system interface table. A system interface table is a model of attributes that captures all of the detailed level requirements for a single system interface. So for every system interface, there will be detailed level report requirements. All the requirements about that single interface would be captured in this table. This is system interface table. This system interface table is in a tabular format and typically includes attributes such as source system, target system, volume of data passed, security or other rules, and the actual data objects passed. Next table would show you that an example of the system interface table for the interface between the grocery store and the customer mobile device. So for every interface within the whole system you are designing, you will have this interface table. This system interface table specifies that information about the store and recipes are synced daily from the store to the mobile device. So both of these data about the store and the recipe is actually going down to the mobile device of the customer. Let's look at the example of a system interface table. This is our system interface table, and the system interface is described. What is the source? Store is the source. What is the target? Customer mobile device is the target. ID of this system interface is MS01. Description is it passes store and recipe information to mobile application. Frequency is daily. Volume is less than 1,000. And security constraints, there are none. Error handling, for that you have to see the variable C sync store recipe system flow. Then is the interface objects. What are the interface objects in it? So it is divided into a number of columns: object, field, data dictionary ID, and validation rule. Object in first case is store, and the field is store number. And then a data dictionary ID code for the store number is RM02, and it is a positive integer. Then second object is again from the store, and it is a store map, and this is in shape of a JPEG image, and it has been given the data dictionary ID as RM04. Recipe text. So recipe text is a field. RM01 is well-formed structured text. That is the text data. Then from store, item overlay is RM06. Again, this is well-formed structured text. Usage of this interface table are used to specify the details for each interface between the system and the solution. Typically, these tables specify requirements for both the source and or the target system, but it could be only one of these, either source or target system. The attributes of a system interface table ensures that details about the interface are not forgotten. So, the interface has been described. What is the relationship to the requirements? System interface tables are detailed enough to represent the actual interface requirement. So they represent the interface requirement and do not need to have other requirements written. So this is the final requirement about the interface. Third is the user interface flow. A user interface flow displays specific pages or screens within a functional design and plots out how to navigate the screens according to the various triggers. The boxes in this diagram are main screens in the user interface as it appears on your mobile. The lines show the flow allowed between screens. In the next figure is a user interface flow that shows the transition between the screens in the mobile application. For example, a user can move from login screen to the register screen to the search recipe screen or directly from the login screen to the search screen. So here is the user interface flow, how the user can go from where. So a user can log in on top. If he doesn't have an account, he can register and then log in. He can search the recipe. He can have his preferences. He can select a recipe and then view the recipe after the search. After he has selected the recipe, he can search the store. If the store is not found, he can search again for another store. If it is found, the store results are displayed and the select store process from the store map. Usage of this user interface flow, typically these flows are used in the solution definition stage of a project and help track all of the screens that need to be further defined. This model is applicable only when there is a user interface as part of a solution. Interface flow can be used during elicitation sessions to determine more details about the functions that take users between the screens. So if you can describe to your customer how the things are flowing. They can add something. They can tell you that this we need to have something added to this flow, or something is not understood. So you can make them understand and correct the model accordingly. So as far as the requirements are concerned, this model does not reflect individual requirement statements. This does not just shows the flow. The user interface flow can be traced to other requirement models such as display action response model, process flow model, or any individual requirements. Fourth are the wireframes or display action response. The display action response model is used in conjunction with wireframes or screen mockups to identify page elements and the functions, if any, they are attached to. Each wireframe is broken down into user interface elements, which are then described from a display perspective and a behavior perspective. A user interface element table is created for every element on the screen that has user interface requirements. Each table describes the user interface element's display requirements under different preconditions and behavior requirements and user actions. While this type of user interface analysis is sometimes performed by user experience analysts or human factors experts, the business analyst is often called upon to perform this function. In general, user interface analysis focuses on profiles of the users who interact with the system and precedes interface design. The business analyst, working in conjunction with the user experience analyst when one is assigned, analyzes the user interfaces to see how well these interfaces meet the general principles of a human-machine interface. So basically, the user friendliness of a system is all about human-machine interface. How convenient it is to interact with the screen, with the machine. General principles for this human-machine interface are the compatibility, consistency, and memory. Capability, it minimizes the amount of information recoding that will be necessary for orbital users. Write once, read anywhere. So once a data is recorded, then you can always access it. Consistency, minimize the difference in dialogue both within and across various human computer interfaces. Follow a user interface standard such as Common User Access (CUA). There is a memory. Minimize the amount of information that users need to maintain in short-term memory. Use reference tables or default information to pre-fill forms. So user may not have to fill every data by himself. So computer program should remember. Then is the structure. Shows users the structure of the system so that they are able to navigate through the interface intuitively. Effective grouping of similar data elements should be done. Feedback provides users with feedback and error correction capability. Something happens on the interface every half second. So feedback is a continuous loop going on, which confirms whether the data which has been entered has been accepted or not, or if there is a error, then the error will display the feedback. So the system will interact with the user. Workload, keep user mental workload within acceptable limits. Individualization, allow customization of the interface to determine the requirements for individualization. That is customization, in other words, and customization means that you can configure your mobile device according to your requirements, language and all that. Then is the collaboration point. Because the information elicited is complementary, the user interface analyst and the business analyst should work together to support each other when eliciting requirements. Example is figure 4.20, shows a simple wireframe mockup of the login screen. 4-21 shows one display action response model for the screen, specifically the display and behavior requirements for the password button. This model specifies requirements to the level of what gets displayed when the user types their password. This privacy dots are what happens when the user selects a field keyboard appears. So here it shows the wireframe or the display action response, how the things would be there. It's a kind of a mock-up on which the logo will appear on top, which it has its own number. The username, again, it is MS002, password MS003, and then you have a button for the login MS004, and if you are not having a login, you can press register, and that is MS005. So there are 5 elements displayed on this display action response. To describe that, this UI element password field is described as follows. ID is given, MS003. Description is a field for the user to enter their password. So this kind of element would be created for every one of those IDs, UI IDs. UI element display is precondition is on login screen, and this is to display the field. No text entered, then it should be grayed out password. That means so far nothing has been entered. If text has been entered, privacy dots are displayed for character, like asterisks appear when you type your password. UI element behavior, precondition, action and response. Precondition is on login screen, select field. And the response is keyboard appears. If the precondition is text entered, then enter additional text, privacy dots per character appear. The usage of this model is helpful when there is a user interface for a solution. The display action response model is typically used when precision is needed for detailing the display and interactions in a user interface. This could occur when defining user interfaces for a large number of users, high-risk user interfaces, and when a development team is unfamiliar with the product. These models are helpful for specifying user interface requirements because the model places the individual requirement statement in the context of the element on the screen. What is the relationship to the requirement? This display action response model traces directly to the wireframe, user stories, user interface flows, and the data dictionaries. These models contain user interface requirements and do not need further specification. This brings us to the documenting the solution requirements, that is 4.11. Before I can start that, if you have any comments, you can speak now.
Sir, what is the wireframes?
Wireframe is mockup. You understand what is
Sorry?
mockup? Mockup. Wireframe is mockup.
No, sir.
Hmm? You,
No,
you
sir.
you don't know what is mockup?
Maybe I am it I name is with I call them with some other name, but
Okay.
I don't know what is mockup.
Mockup is a dummy screen of, if you are developing a software or a mobile application,
Okay.
how will
Mm-hmm.
it appear, and what buttons and characters and whatever will appear on the screen. So this is not a working
Okay.
model. This is just a demonstration to get it approved from the customer. So this is called a wireframe or a
Okay.
mockup.
Okay. 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 Got you. Right.
Okay, to document the solution requirements is the next topic, and in this, let us talk about it. After analyzing all of the information that has been elicited, the business analyst documents the resulting requirements in one of many forms, depending on the organization, the project needs, and the project lifecycle being used. Regardless of the form the requirements take, when packaged together, a set of requirements defines the solution scope to the business problem or opportunity. The business analyst prepares the requirements package so that the solution team understands how to develop the solution. So the requirements pack points towards the solution. So once you pack these requirements together, we clearly understand what is the solution being developed. The business problem is described. Solution scope is clarified. It is defined. And then a business analyst prepares the requirement package so that the solution team understand how to develop it. They will now uh, convert it into solution. So first they will be given this understanding, and then they will start working on the solution. Documentation can be produced in various levels of formality and in many forms, and is often dependent on the selected project lifecycle. The solution may not be the complete solution, as in the case of a project following an adaptive project lifecycle, but it should represent the solution based on the information available at that point in time. So, if we are looking at a solution, this solution is only for the current iteration. We are not looking for the complete solution, but it will contribute towards the complete solution. Documented requirements serve a multitude of purposes, such as baseline to validate the stakeholder needs, baseline definition of the solution for the business problem or opportunity, primary input to the design team, the developers, testers, and quality assurance, basis for user manuals and other documentation, whether written or embedded. So this is why we document. These are the reasons why we need to document. So we provide the baseline as if the stakeholder needs are validated. We provide a baseline definition of the solution for the business problem or opportunity. We provide the primary input to the design team, and we provide a basis for user manuals and other documentation, help files, everything else which is to be written after that. Supporting detail for contractual agreements when applicable, that is, the requirement are a core input to a statement of work for a request for proposal. If you are going for a request for proposal, starting point for evolution of the solution, foundation for reusability by other project teams who need an understanding of the project details while it is in process or after implementation, baseline for an audit of regulated industries and high-risk projects that are required to have documented requirements. Despite the importance of documenting the requirements, keep some factors in mind about requirement documentation. The requirement documentation is only one of several techniques to ensure consensus among all the stakeholders as to the behavior of the solution. Documentation should not replace communication and collaboration. You should not expect that because the thing has been documented and everybody is supposed to know it by themselves. Normally, documentation, though complete, may keep lying in a cabinet and nobody would ever consult it. So we don't want to do that. We actually want to use this documentation which has very carefully been developed. So it has to be properly communicated and collaborated, and in other words, must be used. Business requirements are the goals, objectives, and high level needs of the organization and provide the rationale for a new project. Business requirements recognize what is critical to the business and why it is critical before defining a solution. So before you can start defining the solution, the business requirement must be made very, very clear. The goals, objectives, high level needs, all that must be clearly defined as if the solution can be wrapped around it. In some organizations, a business requirement is considered to be the high level requirement for which user or stakeholder requirements are then used to document the solution. Other organizations use the term business requirements to refer to any requirement that is not a system or technical requirement. Business requirement may be assembled in a business requirement specification or may be a part of a larger document that contains all of the requirements. Organizations that use spreadsheets to capture requirements may use a hierarchical structure with the business requirements as a starting point. In a requirement management tool, business requirements are often grouped by assigning a category or attribute. Then are the solution documents. Solution documents is the documentation that is comprised of features, functions, characteristics of the product or service that will be built to meet the business and stakeholder requirements. So, whatever were the requirements gathered, this solution document will capture all the functions and features and characteristics of the product as if we are ready to prepare the solution. The work of the solution development team is heavily dependent on the solution documentation because they will be looking at this document all the time because it serves as a blueprint for the product that the solution team is being asked to build. When development work is outsourced, it is essential for the solution documentation to be precise and detailed because anyone who will be consulting this document should be able to know exactly what is the requirement because the outsourced team often lacks the business knowledge that an internal development team has. So we have outsourced this work. They will not care about it until and unless it is particularly specified why and how it is to be done. The business stakeholders have a role to review, validate, and approve the solution documentation. The level of formality for these processes is dependent on the selected project lifecycle. Time and again, we are referring to the project lifecycle because it greatly depends on it. How this what project lifecycle are you using? The solution documentation may be rendered in any number of forms. Some common forms include the requirement document, which may be a business requirement document and are a functional requirement specification, or maybe a system or software requirement specification, whatever you want to call it. In different organizations, we have different names for that. Some people call it requirement document, some call it business requirement document, some call it functional requirement specification, some call it system or software requirement specification, whatever. Deck of user stories must be written. Set of use cases with accompanying non-functional requirements or list of items on a product backlog. So all the different systems we may use, they can be used here. The format of the solution documentation is defined in business analysis planning. Requirements. Product requirements are written at different levels of detail and are associated with different requirement types. For example, business requirements, stakeholder requirements, solution requirements, and a transition requirement, where solution requirements are further categorized as functional and non-functional. So solution requirements can be functional or non-functional, and other requirements could be business, stakeholder, solution, and transition. Within any of these types, requirements can be written into progressive levels of detail. And when this occurs, these can be documented in a hierarchy or with a numbering convention that demonstrates the hierarchical progression. While product requirements describe what is being built or the outcome of the project or solution to the business problem, project requirements describe the constraints and necessities for successful completion of the project. Example here is product requirement describe the length and width of a sidewalk to be constructed in front of a building, along with such aspects as color and texture. So this much is the product requirement. You want a sidewalk and you have specified the location and you have also specified some aspects of the color and texture you want this sidewalk to be. Project requirement. This was a product requirement. Now the project requirement for laying the sidewalk could include number of laborers required, qualifications of the laborers to handle the equipment, size of the equipment, time frame for usage, and any restrictions on labor hours. So you see all the project requirements they include the work involved in constructing that sidewalk. It includes people who will be doing it, their qualification, the equipment, the size of equipment, time frame, and all that. This is all project management. So project requirements are captured in accordance with the product requirements you have specified earlier. The collaboration point here is the product requirements are the responsibility of the business analyst, and the project requirements are the responsibility of the project manager. So this is how these two people interact with each other, because the project requirement is the basis for the project requirement. Categorizations. Requirement categories are used to help group and structure requirements within the documentation. The requirement categories may be determined before starting the documentation effort, or the requirements may be documented first and then the category is decided after. When choosing the categories later, they can be determined based on the actual information gathered. Selecting the categories earlier may provide a structure for use in organizing how to elicit information from the stakeholders, but you could do it both ways. The process of categorization helps expose vague, misstated, ambiguous, or otherwise poorly written requirements. When a business analyst is unable to place information on a requirement in a category, the requirement is likely to be invalid and may need to be revised, expanded, or removed. If your requirement does not fit in any one of the categories, there is a problem. Either the requisite category does not exist. If this requirement has to be there, the category has to be added. Or if this does not, new category is not required, then this requirement either has to be revised or expanded, or maybe it has to be altogether removed. Categorization used in this way filters out the bad or poorly written requirements. So all such requirements which are not valid must be thrown out. Examples of possible filters are: we could have a scope filter, we could have a functional filter, we could have a prioritization filter, we could have a testability filter. So there are various filters for your categorization. As far as the scope filter is concerned, it determines whether a requirement or information is in scope or out of scope, or unknown. Unknown refers to the requirements that are possibly invalid and need to be revised or omitted. We are very clear about the in scope and out of scope. If something is in scope, that will be included; out of scope will not be included. But unknown, we cannot linger around with it. We should decide about it. Normally, it will be thrown out, or if you want to include it, it has to be revised and brought into a shape where it can be entertained as an in scope requirement. Functional filter. Once the functional categories have been determined, any defined functional requirement not fitting into one of the categories can be filtered out, revised, or discarded. Prioritization filter: an arbitrary level of priority, and that depends upon the needs, wants, and desires, is defined and used as a filter to determine which requirements stay or are removed. So those requirements which are not on priority may also be removed. The lowest priority items may be removed. Testability filter: all requirements need to be testable. And if there is a requirement which is not testable, that is a good candidate to be removed. All requirements should be examined to determine if they are testable. Any requirements that are not testable are filtered out and need to be revised. There is a note given here. Filters may indicate the need for an additional classification, implying that the original list of filter elements is incomplete. The requirement specification is a common form for documenting requirements. That is 4.11.4. The requirement specification attempts to specify all circumstances, conditions, actions, reactions, results, and error conditions that could possibly occur in the defined solution. The concept is to create a manual that is followed by the development team to create the solution. Many books have been written on the subject of how to construct a requirement specification and how the individual requirements within that specification should be written. There are several available standards that can be followed. Each attempts to circumscribe the contents and form of the requirement specification. So, there could be different ways of doing it. So, whichever mechanism you use, that would be, defining the content of your requirement specification. Requirement specification is a generic term that includes all documents that contain requirements. These requirements may be high level, business oriented wants and needs are very detailed specifications required to build the new product or service. Formal requirement specifications are more lightweight on projects using agile, lean, or hybrid methods. These teams may produce a 1 to 2 page specification and may include user acceptance testing and trace matrices to holistically describe the product. Documenting assumptions. An assumption is a factor that is considered to be true, real, or certain without proof or demonstration. So when we assume something, we take that assumption, which might not be right, but for the time being, we are believing it to be true, real, and certain, and we do not require any proof for that because this is a placeholder. I do not have the data to prove what I believe, but to fill in the blank, I have assumed some value, and that value would be taken up for the requirements for the time being. But as soon as that assumption is validated or the actual data gets provided, the assumption must be removed. Analysis starts with assumptions, and these assumptions are either proven or disproven over the course of a project. There are many situations where assumptions are valid and warranted. So if there is a valid assumption, that then will be treated as a fact and we can continue using it without any fear of risk. Complete information is unavailable. For example, the business analyst assume that the technical resources to implement the solution will be available when needed. The success of the project is dependent upon something happening in the future, for example, an increase in customer population or a change in consumer interest. Then assumptions. Assumptions are made based on factors that exist currently, but those factors may not exist in the future. The common assumption about a project, for example, is that all members of the team will stay on the project until the project is completed. But this might not prove right. The longer the project, less likely that this assumption is true. But we started off with this assumption and we can move on. Then is the documentation of the constraints. We have talked about assumptions. Now let's talk about the constraints. Project management view of a constraint is that it is a limiting factor that affects the execution of the project, program, portfolio, or a process. So limiting factor, it poses certain hurdles in doing the job of the project, program, portfolio, or process. In business analysis, a constraint is a limiting factor placed on the product or solution. Because you see, in project management, we talk about the work. In business analysis, we talk about the product or the solution. Because we are responsible for product requirements, not for project requirements. Project manager is responsible for the project requirements, so he would be more worried about those constraints dealing with work, whereas business analyst is concerned about those constraints dealing with the product itself. Therefore, there are two levels of constraints: product or solution constraints and project constraints. The collaboration point here is the business analyst is primarily concerned with the product or solution constraints, although frequently project constraints are voiced by the stakeholders during elicitations. Therefore, project constraints are documented by the business analyst and passed along to the project manager for follow-up. So these project constraints will be inherited by the project manager. While some consider all requirements to be constraints on the solution, because both constraints and requirements need to be met, solution constraints are often treated as specific category of requirements. So constraints are considered by some to be a form of non-functional requirement, while others prefer to think of non-functional requirements as the origin of some design. are implementation constraints. So in a way, constraints and assumptions are more like each other. The difference between constraints and requirements is that the requirements are written in a positive voice because they define something that should be done. Requirements should not state that something not be done, while requirements define the solution by stating what solution. Constraints are typically written in a negative or constraining language and limit the solution by stating actions that cannot be performed. So that is the difference between the requirement and a constraint. Constraint is a negative thing. It provides negation, whereas the the requirement is positive. These constraints are placing limitations on how the problem described by the requirements is solved. So requirement is looking for the solution, whereas constraints are placing limitations, hurdles in the way of the work. Solution constraints are best highlighted by being placed in a separate and distinct section of the requirement document. Therefore, the solution constraints should be placed in a separate box within the requirement document. Solution constraints may fall into a few specific categories. Solution constraints could be geographical, they can be about the regulations, they can be about the organizational policy or the culture. Some examples of solution constraints are restricting access to sales information to the region that the customer is located in. This is regarding geography. Prohibition against using certain building material, that is a regulation. Security restriction preventing the use of certain data or system by unauthorized personnel, that is a matter of policy. Limitations on the amount of change that the organization can withstand over any period of time, this is the culture. So you can see different solution constraints, how they can be categorized into geography, regulation, policy, and culture. Project constraints may include project constraint is about constraints about the work of the project. Direction to use predetermined equipment, organizational standards, or a preferred supplier. All these will pose your project constraint. Restrictions such as resource utilization, you can't utilize more than this much resource, message size, timing, software size, maximum number of or size of the files, records, and data elements. So these restrictions are placed on these items. Time as such indicates a restriction of deadline, cost a restriction of budget, and similarly scope. Information needs to be transcribed into high quality, well formatted requirements. So these are the guidelines for the requirement. So the information needs must be transcribed. Requirements that are well written are of higher value to the solution developer and overall project team because these will be clear, concise, and reduce conflict and confusion on what needs to be delivered. So the requirements should be well worded. How requirements are written and documented and the guidelines that help structure them are dependent on the selected project life cycle. Requirements are often written in a text-based format when developing business requirement documentation or solution requirement documents and written in the format of user stories for projects that follow an adaptive life cycle. So if you are using Agile, your requirements will be recorded in shape of user stories. The guidelines for both formats are presented here. The requirements can be more than text and may also take a visual form as well. So let's look at the functional requirement. A well-formatted requirement consists of following elements. So if you want to define a good functional requirement, you must specify these things. The condition, what is what is the condition imposed on that requirement? What is the subject? But is it imperative? Do we need to use the active verb, object, business rules, which may be optional, outcome, which may be optional? A well-formed, detail-level requirement might be as follows. For example, when the new account button is pressed, this is what is condition. The system, which is subject, will shows the order, the imperative. The system will display is the active verb, the new account entry screen, which is another object, allowing the creation of a new account, and that is the outcome. So you see, we have condition, subject, imperative, active verb, object, and outcome all in one statement. So if we can read the statement again, when the new account button is pressed, the system will display the new account entry screen, allowing the creation of a new account. Very simple. So this should be a very well worded functional requirement. The following characteristics serve as checklists when reviewing the requirements to ensure they are of high quality. The guidelines address the writing and not the format of the requirement and are applicable to any format or rendering of the solution document. Following characteristics are present in all requirements when they are of a high level of quality. The requirements must be unambiguous. They must be clear. No ambiguity. They must be precise. They must be consistent. It should not negate itself. In the same sentence, initially you are saying something else and later on you change your stance. This is inconsistency. This should be consistent. The requirement should be correct. You should not give out wrong requirements. They should be complete in all aspects. The, the function you want to achieve through this requirement must be completely defined. You cannot leave it half. It should be measurable. We should be able to measure and check whether the requirement is complete or not. It should be feasible. It should be traceable. You can trace this requirement back and forward, and it should be testable. So all of these features or characteristics must be present in the functional requirement. Unambiguous means clarity is the key. Therefore, the business analyst should take steps to ensure that the written requirements are not ambiguous. When two individuals disagree on the meaning of a requirement, or when an individual interprets a requirement differently from its intended meaning, then the requirement is ambiguous. The requirement needs to be rewritten to remove the ambiguity. What is causing the problem? What is causing the confusion in the statement? What can be misinterpreted? So any misinterpretation must be removed, and you must remove the ambiguity and make it more clear. Clarity is the key. If the requirement is not clear before requirements are baseline, stakeholders may have different interpretation of the requirement. Ambiguity may result in the solution team building the wrong solution component, and others who base their work from the requirement as stated may perform their work incorrectly because they understand it incorrectly. The written requirement should be reviewed to see if it can be stated in a simpler or more straightforward manner. For example, in this table, example of an ambiguous and unambiguous requirement. Ambiguous requirement. A system shall check the name field to be only alphabetic and the address field to be either alphabetic or numeric, but containing only address in the US or Canada, and the quantity field to be only numeric. So, lot many things are given here, but these things have to be clarified one by one. So you should say the system shall validate. Number one, name field is alphabetic. Address field is either alphabetic or numeric. All addresses are in US or Canada. The quantity field is numeric. This is concise and unambiguous. Make the things clear. Such a long sentence can be misinterpreted. Next requirement written here is The system provides identification of the employee when passing through the reader. Now, I am not really very clear about it. What does it want to say? When an employee passes near or through the reader, the system provides the identification. So let's make it clear. When the employee passes through the reader, the system displays the photograph of the employee on the monitor. That is exactly what we want it to be defined clearly. That is precise. As a whole, the solution document states precisely what the solution to the business problem is, no more, no less. So, exactly what is required. Precision also refers to choosing the right words. With adaptive lifecycle method, the business analyst should specify at what point the requirements will need to be precise, as the requirement will unfold into details through incremental elaboration. Therefore, it is understood early on that all details may not be known. So, Table 4.9 uh, shows the examples of precise and imprecise language. Let us look at it. Imprecise language is when the department code entered does not match the department code on file, the system will display an error message. Now, what error message are you talking about? This is not precise. You must specify exactly what error message will be displayed. So it says, when the department code entered does not match the department code or the system will display invalid department code. That is a very precise and clear message. Consistent. Each requirement should be included one time in the solution document to avoid contradiction and redundancy. Do not repeat yourself. The requirements should not be in conflict with other requirements within the documentation set. The language needs to be consistent throughout. The same type of language has to be used, as if nobody gets confused. Business analyst maintains consistency through rewrites, revisions, changes, and modifications to the solution document. So he keeps refining. These revisions occur naturally in the iterative nature of the business analysis. As more information is uncovered during elicitation, the business analyst analyzes it and incorporates it into the documentation. The traceability matrix helps to ensure consistency. Traceability is used to verify consistency and is achieved when determining the relationship between requirements. Traceability and traceability matrix are discussed later in section 5. So, in the topic when we'll be talking about traceability and monitoring, so we do not discuss it any further. Conflicting requirements are not unusual. When there are multiple business analysts working on the same set of requirements and performing elicitation separately, one way to prevent contradictory requirements is to assign only one business analyst the responsibility for writing the finished document. So there will be no conflict. Inconsistencies are also introduced in requirements when multiple terms are used to mean the same thing. For example, when referring to the result of the project as the new system, the new account payable system, and the financial system within the same set of documentation, these reading will assume that the document refers to three different systems. So, somewhere you are saying it is a new system, somewhere you are saying it is account payable system, and somewhere you are saying it is a financial system. Use a single term. If it is account payable system, then keep saying account payable system wherever you need to say it. Those reading will assume that the document refers are three different systems. Even though it may be repetitive to use the same terminology, it ensures consistent and unambiguous requirements. Like figure table 4.10 is for example of consistency. An inconsistent statement, the security system will the are in at another place you write a new security system will do this. Then you say the secure card system will do this. The RF security system will do this. Well, why don't you write the same thing everywhere? The security system. Like in the consistent column, it says the security system will do this. The security system will do this. So keep the same name, keep using the same name. Contradictions occur when stakeholders have opposing requirements. For example, two different business units or constituencies may each want their own requirements regardless of how their requirements may impact another stakeholder group. There are few ways of resolving this particular situation. The most direct route is to bring contradicting parties together in the same room and have them work through their inconsistency, and that is the best way of resolving a problem, a conflict. Information can be added to one requirement which details special circumstances that remove the contradiction. So you can update the requirement. It may be necessary to support both requirements. In these cases, requirements for each user group are captured in the form of stakeholder requirements. Example is when one business unit requires 4,000 transactions per day, another business unit requires 2,000 transactions per day. The requirement will be consistent if we stated that 4,000 transactions a day are required during the holiday season from October to December 31st, and 2,000 transactions a day are required for the remainder of the year. So that corrects everything. It has been explicitly defined. The requirement may be rewritten to add more clarity, such as 4,000 transactions a day are desired, but 2,000 transactions a day are mandatory. So the minimum capacity we want 2,000 and we desire that it should be 4,000. Another example, with a single software requirement specification, it is possible to introduce ambiguity by repeating information. When requirements are repeated, there is a risk that a change is reflected in one requirement and left unchanged in the duplicated one. One way to avoid ambiguity incurred through redundancy is to remove the redundancy. For example, the incorrect version could be security. The password will be at least 8 characters in length. User interface, the password will be no less than 8 characters in length. So at one place you are saying it will be at least 8 characters, and then you are saying no less than 8 characters. This is one and the same thing. Why are you using the same, you're trying to redefine it. So you should be saying the password will be 8 characters in length. That's it. And in user interface, you should say the password length is defined in section 7.7.1. So if there is a mention of password again and you want to clarify, then refer it to the earlier section where it was defined or mentioned. Each requirement should accurately describe the functionality to be built. Correctness is not absolute. The solution document is only as correct as the information that has been obtained up to that point. As more information is uncovered, adding new information makes the solution document more correct by removing some assumptions, clarifying ambiguities, and adding new information in a progressive, elaborative approach. The following basic rule helps to ensure correct requirements. Only the product stakeholder can confirm that a requirement is correct. Correctness is established through frequent review and confirmation sessions with the source of information. Correctness is the purview of the business community. The following basic rules help to ensure correct requirements. In general, no single requirement shall be committed to the solution document until it has been confirmed by the second source. In the case of requirement documentation, the second source may be another individual from the business community or a different way of gathering information. Gathering information about a process through observation and then interviewing the process workers who have been observed for confirmation on what has been seen. Completeness is always not absolute. The requirements can be made more complete with more information. Therefore, the guidelines that apply to correctness also apply to completeness. The business analyst should ensure that enough information is gathered and documented to complete the requirement. However, Too much information makes the requirement difficult to follow and convey. Guidelines concerning requirement completeness are as follows. Document all known requirements, especially those that are confirmed by the stakeholder. This includes all conditions that apply to a requirement. Include in each requirement all of the information necessary for the solution team to design, build, and test the solution component. The requirement is said to be self-contained when this is true. A requirement specification is complete when it contains the following. All necessary requirements are there. Responses specified for all inputs. Requirements that produce all necessary outputs. And the labels and references to all figures, tables, and diagrams. Note, what constitutes completeness is dependent on the selected project lifecycle. So, to look at the example of completeness, an incomplete statement is a card reader shall be the same dimension as indicated by the card size and consistent with industry standards. Now, what do you mean by card size indicated by the card size and industry standards? You should say card reader dimensions to be determined by this date, by this man. Terminate a session, incorrect statement, incomplete statement. Terminate a session after the number of incorrect passwords exceed the maximum allowed. What is maximum allowed? How many times he can try? So terminate a session after 3 incorrect passwords has been entered. Note, what constitutes completeness is dependent on the selected project lifecycle. Because of necessary assumptions, requirements may exist in an incomplete form. Use of the term to be determined is acceptable for use provided there is a date when the information is to be determined, and optionally the name of the person who is responsible for determining it must be mentioned. These should be resolved for a given portion of the requirement before proceeding with construction. The next point is the measurable. Each requirement needs to be independently measurable. A requirement that is measurable provides the necessary detail to understand the criteria for testing. Measurability is usually a prerequisite to testability. Must be able to be measured, must be able to be tested. A requirement that is not measurable cannot be tested. So let us see the example of not measurable. There will be no more than 6 training classes per employee. How would you know that? So the measurable thing could be each employee will have not less than 2 and no more than 6 training classes residing on their professional development profile. So minimum 2 and maximum 6. The new production line shall be efficient. How much efficient? The new production line shall produce an average of 5,000 bottle caps per day. That is specific. That is measurable. Then it should be feasible. Feasibility, we have discussed earlier in need assessment. The focus of the feasibility analysis performed at the forefront of the business analysis work pertains to the work to determine the feasibility of various solution options. The feasibility discussed in requirement solicitation and analysis pertains to the feasibility of each requirement. Feasibility here is conducted at a much more specific and detailed level. The same categories of feasibility used in the needs assessment when evaluating a solution option can be applied here to evaluate the feasibility of a requirement. What are the examples of feasibility? There could be an operational feasibility, there could be technical or system feasibility, there could be cost effectiveness feasibility, and the time feasibility. Operational feasibility means when the solution requirement is met, will the implementation of it within the solution be supported by the stakeholders who use the new product or solution? Ensure a solution requirement for one stakeholder group does not make the use of the product inefficient or unusable to another stakeholder group. So, operational feasibility is that it should be good enough for all who will be using it. Technology and system feasibility. Can the requirement be fulfilled based on the technologies that have been selected for the solution? Ask this question. While the solution as a whole was assessed for technical feasibility, the focus here is on each specific requirement. Involve the solution development team to ensure that each requirement is technically feasible. Technical feasibility is more easily kept in check with adaptive project lifecycle because the project team is working on a small amount of the solution at a time and is collaborating daily, whereas with the predictive lifecycle, there is a risk that the business analyst is not interacting with the solution development team often enough. When following a predictive or iterative lifecycle, ensure requirements are evaluated for feasibility by the solution development team before they are baseline. Business stakeholders will be more disappointed to be informed late in the process that a highly desired requirement was not technically feasible than learning about it early in the process when the requirement was provided. So as soon as we learn of such like requirement, so we should convey it as if the people who are affected, they should not get disappointed. Cost effectiveness feasibility. Does the cost to fulfill the requirement make sense with respect to the value the requirement will deliver to the business? Cost may be one of the requirement attributes that is being tracked. Work with the solution development team, business stakeholders, and the project manager to ensure the cost effectiveness of each requirement is analyzed. A requirement makes sense when the value it provides is greater than the cost to implement it. Can the defined requirement be met within the time allocated for the project phase, or should the features be considered for a future release? A project delay may occur from a single reinforcement, therefore, it is better to know upfront when a requirement will require a level of effort by the solution development team that exceeds the time allocation for the entire development phase. There is no one single factor such as time or cost that determines the feasibility of a solution option or evaluates the feasibility of a requirement. Feasibility is best analyzed according to a variety of factors. There is the traceability. Traceable requirements are those that can be mapped back to the source of the requirement and mapped forward through the development lifecycle. As I was saying earlier, it traces backwards and forwards to a test case that proves that the requirement was successfully satisfied. Requirements may also be traced between the requirement and back to the business goals, objectives, and higher level requirements. So we can walk on that chain. It is important to be able to trace any given requirement back to a source in the event that there are changes to the requirement or other changes that impact the requirement. The business analyst uses the source to identify who to contact when the requirement changes. Within predictive lifecycle projects, from a project management perspective, traceability provides a fairly accurate estimate of the level of completion for development. When all the requirements can be traced to test cases through design and build, the person complete and more importantly, what remains to be completed can be determined by the number of test cases that have been successfully executed. When 100% of the test cases have been executed, then 100% of the requirements have been satisfied, at least in the build phase. Testability is further discussed later in Chapter 5, Section 5. Requirements should be written in a way that allows them to be tested, so it should be testable. When a requirement is not testable, it is typically because the requirement is vague, unclear, ambiguous, or has violated some other principles or writing guidelines for quality requirements. Testable requirements allow for an assessment of pass-fail. If the requirement is written to be measurable, then the requirement can be tested. Confirming the testability of a requirement does not mean creating or writing the test case for execution during the test phase. Confirm only that a test can be created to verify that the requirement has been satisfied. Sometimes evaluation criteria are constructed in the case of the development of user stories. For more information on the evaluation activities, we have to go to section 6. How requirements are prioritized should be fully defined in the business analysis plan. Section 3 on business analysis planning discusses the criteria that the project team may use to prioritize the product requirements. The business analysis work in requirements elicitation and analysis is performed to use one or more prioritization techniques in order to facilitate priority decisions from the key stakeholders. The key stakeholders here are those stakeholders who have the authority to prioritize requirements as specified during planning. Prioritization scheme. There are several methods to evoke prioritization of requirements from the stakeholder community. Many business stakeholders may find it difficult to make decisions regarding prioritization as they may see all of the requirements as equal or at least the requirements they provide. Drive the prioritization decision from the business by using one or more of the following techniques to help support the prioritization activity. First is the Moscow. Moscow means O's are silent. First M stands for must haves. Second S stands for should have. Third C is could have. And W won't have. So as far as must have is concerned, this is a fundamental requirement for the project success. So it must be completed. Should have. This is an important requirement, but the project success does not rely on them. So if we can have it, we should go for it. But if we don't have time or anything, then probably we will leave it out. Could haves can easily be left out without impacting the project. So if you can add it, that is good enough. But if you don't, there is no harm. Won't have. This is a kind of a constraint, a restriction, not delivered this time around. This thing is not to be delivered. Then we have got multi-voting. I hope we have somewhere talked about it. There are many forms of multi-voting that are designed to gain active participation from stakeholders. This technique provides a process for participants to apply votes to a list of items to determine any answer based on number of votes received. When using multi-voting for setting priorities, the requirement with the most votes is deemed the higher priority team. Example is when applying multi-voting to determine a list of prioritized requirements, each stakeholder could be given a set of sticky notes or sticky dots in three different colors: red for high priority, blue for middle priority, and yellow for low priority. With the requirements on a whiteboard or flip chart, the stakeholder places one or more of their sticky dots next to the requirement that believe merits the priority. Participant can place all of the red sticky dots next to a single requirement believed to be the highest priority. Once all the dots have been placed, the dots are totaled and the requirements prioritized. The game-like atmosphere of this approach makes it easy and fun for stakeholders to prioritize requirements. Then is the tool of time boxing. Time boxing is allocating a specific amount of time for each iteration, and the work you have picked to do in that iteration is the matter which has to be handled by the project manager. Time boxing is a prioritization technique that is used when the project has a fixed timeline and the timeline is not negotiable. Time boxing approaches the prioritization of requirements by analyzing the amount of work the project team is capable of delivering during a prescribed period of time. The project team determines the scope based on what work can be completed within the fixed window of time. If the time box is 90 days, the project team evaluates the list of requirements and determines what can be delivered within that 90-day window. So whatever is the size of a time box, that size of an iteration, time box will be according to that. Time boxing is often used when other prioritization techniques such as Moscow to ensure that the requirements time box into the product release are those the business has selected as the highest priority or highest value. A variation of this technique uses money instead of time to determine which requirements can be delivered based on a budget. There is a weighted ranking. We have already talked about it. Weighted ranking begins in business analysis planning before the possible solution options are listed. Prior to performing weighted ranking, the business analyst facilitates a decision regarding which criteria the decision will be based on. Possible options are efficiency, ease of use, attractiveness, etc. Once a short list of criteria has been selected, the criteria are ranked with a score. The highest score is assigned to the criteria considered to be most important, thereby creating the weighted rankings. Weighted ranking is further defined in Section 2 on needs assessment, where it is used to rank solution options. Projects may require more detailed technical documents, software IT, construction, manufacturing projects, to name a few. The requirements are documented in the format of a technical requirement specification. So technical specification may contain wireframe describes the appearance of a user interface. Screen mockups specifying the detail of the user interface. Data model and schema. Probably you can't see, but where it is necessary you have to do it. Detailed process flows such as data flow diagrams or activity diagrams and detailed requirements that include technical reference. The collaboration point here is the IT project. Some organizations have a system analyst who produces the technical specification, dividing the requirements documentation between the business analyst and the IT analyst. The business analyst that produces the business requirement specification and the system analyst prepares the technical requirement specification. In this guide, the role of business analyst is preferred to the general system sense. Therefore, the work to produce the technical requirement specification is included as a possible documentation activity, recognizing that the documents that are produced will be dependent on the selected life cycle, project life cycle. Use cases may be used by an organization in addition to a functional requirement specification or used instead of producing a separate functional requirement specification. A use case may represent one or more functional requirements. Use cases may be supplemented text-based requirements and are developed for areas of the system where the interaction of the system and the user was more complex. Use cases may be used when there are multiple paths and scenarios that the system needs to accommodate. Instead of creating a functional requirement specification, some organizations may decide to use cases and will choose to use models such as those discussed in this particular guide instead of text-based requirements. The decisions regarding the preferred documentation approach for the project is made in business analysis planning. Use cases are explained later on in 4.10, 7.5. A documented user story is sometimes written in an index card. Write the story on a card enforces brevity and conclusion. When cards are not used, maintain the stories in the document spreadsheet, or requirement management tool. When packaged together, user stories represent a high-level version of the system requirement. User stories are a documentation method for breaking down features into manageable parts, just like we are breaking open the work breakdown structure, and provide a simple and effective mechanism to segment a complex set of features into simple, definable elements. User stories are explained in a later section. Backlog items. Backlog is a prioritized list of project requirements and deliverables to be completed, often written stories and prioritized by the business to manage and organize the project work. As the use of adaptive lifecycle has become more prevalent, the concept of building a backlog has gained in popularity and across approaches. When backlogs are commonly leveraged to contain only user stories, the team can be used more broadly as backlogs may contain use cases, requirements, and defects to be fixed in addition to the user story. Regardless of the content stored in the product backlog, to ensure clarity, each item should be written with the same care and follow the same guideline as a requirement expressed in a business requirements document. In agile approaches, the business analyst is often assigned to help the product owner groom the product backlog, which involves adding and removing backlog items and reprioritizing based on changing business conditions and priorities. Let me have a little break to take a sip of water, so I'll get back to you. Ji, are you there?
Yes, sir, I'm here.
Okay, Ji, let us start. Next topic is validate the requirements. That is 4.12. Validation is defined as the assurance that a product, service, or system meets the needs of the customer and other identified stakeholders. So that is an assurance you get that this has been completed. In business analysis, requirements validation is the process of ensuring all requirements accurately reflect the intent of the stakeholder, thereby ensuring the requirements meet their expectations. So you confirm with the identified stakeholders whether the requirements have been properly recorded and are they correct requirements or not. So this is the final validation. After that, the requirements will go into action. And this confirmation of requirements can occur whether the requirements are written down in a requirement document or are displayed on a whiteboard in a requirements workshop. Confirmation is not an activity that is performed once at the end of the requirement process. Confirmation occurs whenever the business analyst reviews the information gathered during an elicitation session with the stakeholders or any part of the developing solution is shown to the stakeholder. So we keep getting the confirmation from the stakeholder continuously. Confirmation does not mean that it is an approval. It is only authorized stakeholders can approve. Confirmation means obtaining agreement from the stakeholders that the solution under development is good and will accomplish the objectives. It is helpful to demonstrate parts of the solution as it is being completed. It is easier to obtain low-level confirmation on a continuing basis than to try to have the entire solution document confirmed approved at the same time. When the requirements are broken up into small self-contained units, the review sessions involve fewer participants and take less time. It may be helpful to divide the requirement document up by functional areas and ask stakeholders to confirm the requirements that impact their area. This requires more work, but stakeholders will appreciate being able to focus specifically on their own requirements. There is a risk, however, that the separation of requirements may not be correct, and stakeholders impacted by a group of requirements may not be provided with all of the requirements that will impact them. So, requirement walkthrough are used to review the requirements with the stakeholders and to receive confirmation that the requirements are stated are valid. Valid requirements accurately reflect what the stakeholders are asking the solution developer to develop. To conduct a requirements walkthrough, the business analyst schedules the session providing the stakeholders enough time to prepare. Reviewers may be asked to read the materials before attending, and by doing so, the reviewers will be able to think about the stated solution ahead of time, better preparing their feedback, avoid providing emotional reactions to the material in the session, and take time to discuss the material with their organizational units and peers so that feedback provided is representative of the larger stakeholder group. The flow of information in a review session should come from the reviewers as much as possible. This session is one of the final opportunities for stakeholders to raise questions, seek clarity, and voice concerns. The business analyst can use this session as an opportunity to field questions and seek to close down any open requirement related issues in preparation for receiving final approval of the requirements. So, next topic is verify requirements, that is 4-13. What is verify? We have just talked about the validation of the requirement. Now we are talking about verifying the requirement. Verification is the process of reviewing the requirements for errors and quality. So wherever there is quality, we do verification. This assurance is for verification. The requirements have no errors and they are of a certain quality. So we do not need to go with a stakeholder for that. Verification may occur before or after the validation. Verifying requirements after they have been validated or confirmed by product stakeholders ensures that only the requirements that are considered to be good requirements are verified. Validation is concerned about ensuring that the requirements solve the problem. Verification is not. Verification does not ensure that the problem will be solved by these requirements. Verification is just looking at if there are any errors or bugs, if there is a problem in quality, that is assured. As far as whether the problem will be solved or not, that is a question to be asked by the validation. Verification is performed by members of the solution team to ensure that the requirements meet quality standards or any other business analysis deliverable in the process meets the standard of excellence for the organization. There are two types of verification processes: peer reviews and inspections. First, talking about the peer reviews can be conducted at any point during the requirement process. The business analysis of peer review is a formal or informal review of the requirements by the peers of the business analyst. Business analysts may include other practitioners such as their managers or someone in the business analysis center of excellence. Quality assurance or testing sources also make great reviewers. The purpose of the peer review is to ensure that the written business analysis deliverables, including all forms of requirement documentation, are in compliance with the organizational standards and generally held principles of the requirements writing. Section 4.11.4 contains examples of these guidelines, which we have already discussed. This helps to ensure there are no glaring errors in the requirement that could cause problems during the review. Poor peer reviews may also be held after the review sessions with the business stakeholders to ensure the final document is understood and accepted by the solution team and development community in general. Conducting a peer review is fairly straightforward. All reviewers are provided with a copy of the document and asked to review the document prior to attending the peer review session. The requirements are reviewed as a group with each reviewer pointing out issues or problems in the document. A form of screen sharing technology can be used to display the document and make changes to it during the meeting as issues are discussed, thereby saving time and ensuring the errors raised are properly fixed. When a formal session is not conducted, the document can be distributed to the peer review team electronically, asking the reviewers to track their changes in the original document. For organizations who use a requirements management tool, there are a number of features that can be used to track the comments provided by document reviewers. Collaboration point could be ask testers and those involved in developing training in manuals to be part of the verification review. This provides these team members with the project background and context early on. These team members will focus on the details and check for consistency, completeness, and testability of the requirement, which is beneficial for the verification review. Then is the inspection. Inspections are a more rigorous form of a peer review. The inspections were initially targeted for hardware development and were later modified to be applicable for anything that needs to be reviewed for accuracy, completeness, and relevance, etc. In predictive lifecycle process, requirements inspection are typically performed once at the end of the requirements process when the document is ready for final approval. Often inspections are performed after all of the business stakeholders have had a chance to review and confirm their respective portions of the requirements. The objective is for the business to ensure that the requirements are acceptable in their current form. Inspection can also be performed on groupings or chunks of completed requirements. This inspection is performed by peers who participated in the creation and documentation of the requirement and are the recipients of the requirement document. Business stakeholders and management are excluded from an inspection session, especially the line management of the inspectors. Our requirements inspection checklist should include are all the internal cost references to other requirements correct? Are all the requirements written at a consistent and appropriate level of detail? Do the requirements provide an adequate basis for design? Is the implementation priority for each requirement included? Are all external hardware, software, and communication interfaces defined? Have algorithms intrinsic in the functional requirements been defined? Is the expected behavior document for all anticipated error conditions? A checklist differentiates an inspection from a peer review. A peer review depends on the knowledge of the reviewer, whereas the inspection uses a checklist of known defects for the product being inspected. Inspections also follow a more rigorous process than peer reviews and use a series of rules to govern how they are performed. 4.14 is approval sessions. Approval sessions are conducted separately from confirmation sessions. After the solution is confirmed and validated, the business analyst obtains sign-off on the requirements. Sign-off may be formal or not and may be predetermined in business analysis planning. When signatures are sought, there are three signatures that are usually requested. Number one is a business owner, such as the executive in charge of the business area, who agrees that the requirements represent a complete and accurate solution to the problem. Solution team recipient, who accepts the document and acknowledges that it is sufficient to build the documented solution. Business analyst, who prepared the deliverables. Obtaining approval from the requirements should be a fairly automatic process. It is rare for a person of authority, such as a vice president or director of the company, to take the time to thoroughly read and analyze a complete set of requirements for any given project. They may ask someone closer to the project whether the requirements are acceptable. Since the requirements are confirmed to be correct, accurate, and understandable and implementable, etc., by all of the individual constituencies, obtaining approval from a senior manager should be a routine process. Problems in obtaining approval arise when the lower level managers or process workers have not seen the requirements yet and are unable to provide a positive opinion about them to the senior management. For more information about the requirements, approval process, see section 5.4, which will come later. 4.15 is the resolved requirement related conflicts. Conflicts may arise at any point in the business analysis process, whether the conflict is between business units voicing opposing views of what the solution should be, or a solution team and a product stakeholder disagreeing on the way to solve the business problem. The first order of business is to determine what the problem is and that parties are attempting to solve. The business analyst mediates the situation by discussing the differences and by understanding the points of view of each stakeholder. Several discussions may need to occur before a resolution is reached. When unable to reach a decision, the issue needs to be escalated. The process for making decisions, resolving requirement-related conflicts, and the escalation path to follow when negotiating efforts fail should have been defined during the business analysis planning. Business analysts require soft skills in negotiation and need to learn how to bring opposing sides to consensus. Facilitating a win-win solution is key. The business analyst also should be capable of analyzing the reasons as to why the conflict exists. There are numerous techniques that can be used to help a team reach a decision or resolve a conflict. Techniques remove subjectivity and emotion from the process. A few examples are: number one, the Delphi technique. Delphi technique is an informal information gathering technique, such as a way to reach consensus from experts on a subject. Experts on the subject participate in this technique anonymously. The facilitator uses a questionnaire to elicit ideas about the important points related to the subject. The responses are summarized and then recirculated to the experts for further comment. Consensus may be reached in a few rounds of this process. The Delphi technique helps to reduce bias in the data and prevents any one person from having undue influence on the outcome. The Delphi method relies on peer pressure and the wisdom of crowds to produce the correct decision or solution. This technique works well for teams organizing from diverse locations. Then is the multi-voting. When applying the multi-voting technique, which we have tried out before, to resolve a conflict, the team brainstorms to generate a possible list of options for resolving the conflict. The team decides how many items would be on the final list. All of the items remaining after a first cut of the brainstormed answers the question are then numbered. Each participant receives a limited number of votes and is asked to place the votes against the unranked choices. For example, when provided with 5 votes, a participant is able to place 3 votes on one choice and 2 on another. When all members of the team have voted, the votes are tallied and the result posted. When there is a clear decision, the process ends. Otherwise, the total list is adjusted by eliminating those at the bottom, and the process is repeated, this time with fewer votes per person. In the end, the decision is based on the basis with the highest score. Weighted ranking, again, we have talked about it. The same weighted ranking technique used to rank solutions of options is in need assessment, and the prioritized requirements in requirements elicitation and analysis is applied to resolve requirement related conflicts. The technique is applied in the same manner. Options are listed, ranked, and voted upon. Options with the highest score is selected. Options are typically solution related. For example, in the case of two requirements that completely conflict with each other, this technique does not compare the requirements for each other, but instead compares the differences between the solution options that represent the requirements. So this brings us to the end of today's lecture. And if you have any questions, you can talk now.
No, sir, I understand the techniques. I think we at currently we are following the time boxing. Time
Okay.
boxing, yeah. Yeah. But we are not following any weightage and that prioritizing
Hmm.
technique.
Okay.
But I remember that we with our client bank we used to do the there was some they actually do the poker technique. I don't know
Okay.
if you know
So
about that
yeah,
poker
yeah, of
technique.
course, of
You know,
course.
for every requirement, their team, the business team, and we the business team and the project team
Hmm.
used to sit down and we have the cards. We show up the card for every requirements. We give
Yeah,
some every card has the different numbers. So
yeah.
we
That
used to do that, and if the number is higher, then we have to, justify why we have
yeah,
selected
exactly.
this number, why we are giving this requirement, this
This is
number.
called
So we have not
Fibonacci.
discussed that poker technique over
Yeah,
here.
this is the Fibonacci number. This is when you are collecting the requirements. Yeah, this is very much there in Agile. This is very much there in Agile
Hmm.
because it is an Agile technique. So probably he is talking about the overall business analysis, and maybe somewhere he mentions that, but it is not. I'm not sure that he discusses it anywhere.
It is used. You are saying it is not used anywhere.
No, no, it's used in Agile.
Hmm.
It is used in Agile, and it is a very important tool for Agile. You have to defend it,
Okay.
you have to convince other people, and then they vote again and again and again, and until and unless they reach a conclusion. A older form of this is the Delphi technique, which I just taught you. Delphi technique is, as it was told, um, this is anonymity in the opinion. We want to keep the opinion of the people anonymous, and then we collect
Okay.
ideas from people, list all those ideas down anonymously on a piece of paper without writing their names, and then we circulate those that complete list back to each and every one, and we ask them to uh, say select top 10 options, right? So we are doing it
Hmm.
anonymously. So everybody will pick top 10 and will give me a list back, and I will again compile it, and again we will have a long list. I will pick the top 10 again, and again send these top 10 to everyone. and then I'll ask them to verify which they want to keep, maybe the top three. So we'll keep doing
So
these rounds.
is it the lengthier way of doing? I mean, is it the lengthier way of doing prioritizing the requirements?
Yeah, of course it is, but this is a old, very old method, and it is a very lengthy method. It takes days and days and days, and you don't need to be sitting in a meeting. But a modern method of doing Delphi is that you use post-it notes. You tell everybody to write their points on a post-it note and submit it, paste it on the board. So once all the points are there on the board, then they are voted, and multi-voting is carried out, and ultimately we are able to decide something. Multi-voting is also a kind of a Delphi technique, which is a fast Delphi.
Okay, in multi-voting. So
Yeah.
everyone will vote for the requirement, prioritize it, the requirement according to
First
them,
off,
right?
all the points are summarized in front of everyone on the board, right?
Mm-hmm.
Then you are given certain number of votes, like sticker sheets or
Mm-hmm.
small round stickers or star stickers.
Sticky note.
Sticky notes, not exactly sticky note. It's like stickers. So
Okay.
there's a star made out of it, and you have got say 10 stickers, and you are asked to vote on these points. So you can give one vote to the most important points, and then that way you will use all your 10 stickers. Or you, if you like, you can put all the stickers on one point, right?
Okay.
Or maybe
Right.
you can divide them, three here, two there, and so on and so forth. So they will ask everybody to put their stickers on the board. So people will keep voting, and ultimately, when the voting is done, then they will count the number of stickers against every point, and then they will sort them in order of priority, right? And then they will pick top 10, and that would be the answer.
Okay. Right. Right, sir.
So we are meeting tomorrow, and we will be starting the new chapter. That would be chapter number 5.
Yes, sir. Yes, sir. Sir, I have a question. Can I copy those lectures in on my drive, or I can copy on my hard disk?
You can download them, of course. Why not?
Okay. Okay. Right.
I have, I think, placed lecture till last lecture there, and the new lecture. This will be copied there as well, and you can use them,
Okay.
of course. Why not?
Okay, sir. Right.
Okay,
Okay,
thank
sir.
you very
Thank you,
much.
sir.
Thank you very much. Take care. Bye.